Welcome to Embedded. I am Alicia White alongside Christopher White. Our guest this week is Professor Nikolaus Correll, and we are going to talk about robots, which of course is one of my favorite subjects.
Hi, Nikolaus. Thanks for joining us.
Hi, Alicia. Hi, Chris. Nice to meet you. Thanks for having me on the show.
Could you tell us about yourself as if we met at, I don't know, a faculty new orientation dinner?
Yeah, I'm a professor in computer science for 15 years now at the University of Colorado. And I do research in robotics. And most recently, I started looking into generative AI models and humanoids and apply those to robotic manipulation.
And of course, that's where I have all the questions. But first, we want to do lightning round, which is short answers and we want it's short questions and we want short answers. And if we're behaving ourselves, we won't ask for a lot more detail. Like, can I be your grad student? Are you ready?
Yep. Thank you.
You're really going to make me ask this question? This is listed in the thing. I didn't come up with this. Which is better, Caltech or MIT?
I think MIT is probably better. More people.
Well, I'm glad I didn't put Harvey Mudd in there because he would have just said, there's no people there. Yeah.
But it's a mean question.
It is a mean question.
It has a history.
Other than Robotics 101, what is the single most important college class when learning robotics?
Discrete mathematics, probably from a computer science perspective.
If I was looking for a robotics grad program, what would be some things, the various schools that I should look for?
Yeah, that's a good question because we just started a robotics grad program. And of course, it's the faculty and it's critical mass. It's relationships with industry. And I think mostly cool research going on at the university that you're interested in.
All right. Well, I have so many robotic questions that I'm actually going to cut this short.
Well, you have to do favorite fictional robot.
Okay, right. What is your favorite fictional robot?
It's the T1000. The T800. Because in the nice version with the upgrade, the Arnold Schwarzenegger, and he comes back, Terminator 2.
I'll be back.
Okay, so you have a book called Introduction to Autonomous Robots. Could you tell us a little bit about it? Who should read it?
Yeah, so the book came about for teaching robotics to computer science students. And I started it maybe 15 years ago as an lecture notes, an open source book. And then a few years back, as our robotics faculty grew, my colleagues joined the effort and we then published it with a real publisher. And the goal is still to really provide everything computer science people need to know. Of course, other people who want to build robots are equally addressed, but the focus is, or the approach is very much for people who come from programming or want to program the robot versus building robots from scratch.
I know this is a silly question, but can you define what a robot is? Because I think, lay people think C-3PO, engineers think anything with a servo motor and code running, and it is probably, a mix of things. But what do you think what is your definition of what a robot is?
So you definitely know one when you see one. Giving an equally mean answer that has a lot of depth to it. But it's a difficult problem. And in the class, we usually start doing that by showing people different things like an elevator, a coffee maker, an autonomous car, and also C-3PO-like things. And then we ask them, okay, what is a robot, what is not? And it's very difficult to define that. And so it has to have a confluence of sensing and actuation, so it has to move, and that has to be wired in some kind of intelligent, non-trivial manner. But then when you look at very simple robots where the sensing is directly wired to the actuation, I think there are also robots already, like insect-like things. And it's probably almost as difficult to ask what is life. So where does life start, and what do you really need? What are the ingredients? Is it a certain complexity where that mechanism then becomes alive? So sorry for digressing, but the robot question is equally difficult to answer.
Yeah.
I like, going back to your book, I like that it's for computer science folks. One of the things that I always have trouble with is the mechanicals of it. I mean, in your course on Coursera, which is connected to the book, is it connected to the book?
Yeah. The Coursera course follows the book.
You use the WeBot simulator, which is sort of ROS 2 gazebo made much, much, much easier. What made you decide to use WeBots?
It's a scaling issue to teach the class to multiple people or to many people at once. And we always use the simulator. We always used WeBots. And sometimes I taught the class so as a simulator, we never use Gazebo or anything else. But sometimes I try to teach the class using Sparky robots. And then every student could have a Sparky. So you can have like maybe 60 students with 30 Sparkies or something like this. And then they would share. But I also realized that it's becoming very much an embedded systems class at this point. And when you actually use ROS, which we also have done with the Baxter robot, it becomes really a software engineering class. And the people who do not have those skills, or embedded Linux skills, they basically fall through the cracks. And so with robots, you can really focus on the discrete algorithms that drive the robot in the simulator, a few lines of Python.
And I like that about it, but defining the robot has been really difficult for me. I want to do a robot that is very different from what you have in your class or is defined in WeBots otherwise. But the mechanicals part is just sort of beyond me. How do I learn that?
You mean like putting together the mechanics in the simulator, like starting from a wheel and adding like 3D objects to create your own robot?
Yes, I can follow the instructions, but I can't do it myself.
You could. I think I know what you mean. So I let the students in the first, exercise lab session follow the robots tutorial to build some simple robots that drive. And then later I want them to learn how the simulator works in the scene tree and things like this, so that they understand that there's a tree of components, because then later they have to change the robots that are given to them. And I think it's just a matter of expectations. If you can put a humanoid robot together in 15 hours, then it's maybe 10,000 times faster than doing it for real. But you may be expecting to do it in 10 minutes. So maybe that's the problem. And then, of course, the physics are finicky. So I have this one robot, I don't know if you've seen it, the one where there's a side spinning wheel that makes the robot turn once it goes off a cliff. And, setting up the physics right so that this actually works, so the wheel speeds and the friction coefficients is quite difficult. So it requires a lot of tinkering in order to understand the intrinsic problems of the physics simulator. It's, I think, Bullet that they use inside. So that also might create problems if you do that for the first time.
So you're telling me that it's hard. Well, that's irritating.
Do you need to understand the physics to be able to I would imagine that these robots get so complex that you're not going to sit down on a sheet of paper and solve analytically, the equations of motion of the system. Or is that something that people should be considering with maybe simpler robots before going into the model?
Well, I think you need the equations of motion once you want to solve the inverse kinematics problem or even the forward kinematics. So you want to know where things are, like when the wheels turn. But generally, you don't have to build your own robot in robots anyways. You just use one of the many that it comes with. And so I never had to do that, really. So maybe in the class, it's a distraction in the beginning. But on the other hand, I want people to understand how the simulator works. Mm-hmm. So you don't have to be able to build your own. It's really just getting people to the point that they see. I mean, when they follow my curriculum in Coursera or something, I guess that's what Alicia,
yes,
what you refer to. Yeah. Then I really want them to understand how these components work and that they are like discrete elements like motors and sensors that you build this up with. And I think it's good feedback, actually, that this is maybe an annoying hurdle. Maybe one should do easier things in the beginning. And once people like the class or like the content, then let them play with the simulator or learn the simulator, intrinsics.
Oh, it's not really a comment in the class. The class is paced well. It was just that I wanted the class in order to be able to do what I wanted to do, but it's a Weebots hurdle. It's not really a class hurdle. It's a Weebots tutorial that I probably should figure out and then write.
Yeah, I mean, any hurdle is a hurdle in the class, so I think it's good feedback. I appreciate it. I will use it.
So back to, you mentioned the model. You were talking about this wheel that is perpendicular to the normal. Okay, so there's a robot. And you have a really good description of this. And the robot, behaviorally, it is just a little tiny wind-up sort of toy robot, and it goes to the edge, and then it turns. It goes to the edge of the table it's on, and then it turns.
So it avoids falling off the edge.
It avoids falling off the edge.
Okay.
But
I haven't seen this, so
it is done entirely through sensing and actuation. There's no intelligence to it, because when it is going forward and it starts to lean forward, it engages a different wheel that turns it to the side.
Okay, so it's just a little more sophisticated than those 1980s dog robots outside
exactly
Spencer gifts that run around.
As sophisticated as the 1950s wind-up robots.
Okay, all right.
That seems like the simplest version of a robot possible. And according to your definition, it is a robot.
Yeah, that's why I show it to the students and ask them, do you think it's a robot? And I also ask them, how would you build it? I mean, if you had to build it from scratch using your imagination, what kind of components would you envision? What kind of logic do you need? How could you go about it? Would you need a computer? And I think then that is already where the definition becomes really murky, because it's really just mechanistic. But then if you add electronics, then why is electronics any different than a mechanism? It's also just, photons or electrons doing physical stuff. There's no algorithm there. But it's really a conversation starter also in the book. But it also has another component to it, which I think you want to get to also, is it shows how important the overall systems design is. And even if you have a computer in there, the geometry of the mechanism is super important for this to work. And this will stick with the robotics curriculum throughout the book or the class or your roboticist career.
Exactly. And as I said, it is one of those areas that I find personally difficult. How do people learn that part?
I think seeing such a robot, primed for this is very important. And then seeing examples throughout class or in commercial products like the Roomba, things like that. But it's very, very difficult to design and learn that as a design skill. I haven't figured out how to do that or how to teach that. Okay. But I'm also not very gifted at that part. Like, I think there's if you study mechanical engineering, then you will be exposed to many complex mechanisms. And it's kind of a school of thought for that design process. But yeah, animals are, of course, another big source of inspiration in robotics historically, where people look how it's done there.
What are the concepts that most people have trouble with when learning robotics?
So the computer science students often haven't learned what a finite state machine is for some reason, because that's something that is taught in computer architecture, and they write code that runs from the top to the bottom, but they don't have a loop that goes into different states and then has state transitions. And so that is one part, but then the other part is that the code doesn't run, the code just triggers what the robot does, and then physics takes its course. And so while physics evolves, you have to take a back seat and wait until physics has happened. So you, for instance, time your loop or something, and then the robot has moved a little bit, and then you can sense again. And wrapping their head around that is usually new to people, even if they programmed a lot before.
There's a lot that goes into that too, because there's sampling rates, there's how fast your sensor updates and how fast you can read your sensor, which might be just separate things. There's a lot that's just part of your system that's related to physics, but on top of physics.
I feel like being an embedded systems engineer, I'm used to working with the world.
Right.
But yes, I could see how that might be odd. So I have another question. What is the most fun part to teach?
You mean the most fun part for me or the most fun part for the students?
Well, now I have two questions.
Okay, so I like them getting excited about the robot moving and the opportunities they get once they realize that they can very easily create illustrations and visualizations of actually something that they have complete control on, like, you know, the Tiago robot going to the kitchen and picking up items, something they probably didn't expect that this can be accomplished by the end of like a one semester class. And so that happens throughout the class when they engage with the robots and see what happens there. I guess that's also the most fun for them to do. And I was a little reluctant because most of the students actually expect to work with real robots and then are disappointed if they cannot. And I think it's also difficult to appreciate what the simulator does for you if you haven't had that embedded systems robotic experience. So they yeah. Well,
they really wanted things to catch on fire.
No, not only that, it's like, okay, we're 6 weeks in and you've managed to install your compiler correctly.
Oh, it doesn't work? That's just a jiggly wire.
Yeah.
Now I understand why you guys laughing, because that's exactly right. That's the embedded systems background that you're bringing. And they have no idea. I mean, I tell them, look how it's so easy. And normally you have to take a ruler and put it on the table and follow the robot and reset it and carry it through the room. And here you have to do none of this, not to mention all this plugs becoming loose somewhere inside, or things heating up weirdly, and then the behavior changing throughout. So, yeah, I always tell them how lucky they are, but it's difficult to communicate that.
Just make them do the IMU calibration procedure where they have to do the hard and soft iron calibration, and then all of the accelerometers. Do that with the 40-pound robot, and it gets really heavy.
I have to do that with a 40-pound drone. It's horrible.
Yes. It is really weird for me to think about robotics being separate from embedded systems. Maybe that's just my background. Is that a common separation in academia?
Yeah, I think so, because, I mean, historically, robotics or robotic textbooks are about dynamical systems, like the kinematics and then the dynamics of these link chains of actuators. And I don't teach dynamics, but only the kinematics and all this new stuff, I would call it, which is the planning aspects. So there are all these algorithms like from networking, Dijkstra's, where we then have path planning or a lot of probability theory that came in. And so the question is, how can you pack that all into one class if you have to deal with the limitations of the hardware? So, for example, when we used Sparky, which is an Arduino-based robot, they had to implement Dijkstra's in C on a 4x4 grid. And so they don't really see how the path is planned, or like that path planning is difficult. So now they can have a real map that is collected by a laser scanner and plan a map on that. So you can push it much further if you disconnect it, because otherwise the Tiago robot, I don't know how many computers are there and how many sensors and power routing. It's quite a complex system, which might take like a few weeks of just learning how to use it properly. And then I can't teach them all this stuff and have the robot go to the room and pick up something from the kitchen sink, the kitchen counter.
Is it realistic to let the students think that this easy part of robotics can happen without a real robot?
Yeah, it's a good question.
I wouldn't call it easy.
I know, that was wrong.
I think it's really... So at CU, another big deal for them is to program it in Python. And before that, they learned only C++ in our curriculum. So in the third year, then some of them know Python, but it's the first time they really have to go through this. So there's so many things that they don't know and that they have to learn and that this class is using to transform them into computer scientists that we basically pick our battles. Mm-hmm. And I would say a lot of these things that you experienced the hard way and they should experience if they want to go on to robotics is not what all of the computer science graduates, or I don't know how many percent, but I think a large percentage of our graduates take the robotics class because it's some kind of the core curriculum. I don't think these are things they have to know. And so it's really about finding a way to get those people, these computer science people, into the robotics field and then keeping them there and let them take the next class, which is advanced robotics. And that uses the Amazon Racer, which is one of those, remote controlled cars, which you can then make autonomous. And so there they start to get exposed to much more embedded system stuff. So they have to log into that Linux box. They have to use ROS, Ubuntu command line. And then, things like power and, cables coming loose becomes an issue. I don't think they really add sensors on their own. But then they can also all work in the robotic labs and become real roboticists. So it's really just one direction to come in, which is maybe very orthogonal to coming in from a VEX robotics perspective or from a Arduino-based perspective.
But these algorithms are important, and understanding how matrix math really is very extremely useful in lots of things, but specifically in robotics seems like a good course path.
Yeah, and I already regretted when I said discrete mathematics. The other class is linear algebra.
Yeah.
And maybe that is more important. I'm not sure which one it is. It depends on what you want to do. I think you can probably get away without the matrix math if you use high-level AI planning. But then everything else, you will need to live with it, especially computer graphics, computer vision, and things like that, or even machine learning. Yeah. So maybe we should correct that answer. And so herewith do.
Do you remember that episode on The Big Bang Theory when they suggested adding a Bluetooth to a flower barrette to attract a male audience? Penny asked Sheldon, "Wait a minute, you want to make a hair barrette with Bluetooth?" To which Sheldon replied, "Penny, everything is better with Bluetooth." The right answer was actually, "Penny, everything is better with Nordic Semiconductor's Bluetooth." Because with a 40% share in the Bluetooth low energy market, chances are you have at least a handful of Nordic devices in your home at the minimum. But it's not just about Bluetooth, because over the years, Nordic has become a market leader in IoT connectivity, providing hardware, software, tools, and services to create the IoT devices of the future across a wide technology portfolio that contains not only Bluetooth low energy, but also LE audio, Bluetooth mesh, Thread, Matter, cellular IoT, Wi-Fi, and more. And to thank you for listening, Nordic Semiconductor has a contest to give away some parts. fill out the entrance form, and you're in the running. That link is in the newsletter and in the show notes. Okay, sorry. You have the book, you have a Coursera class. The Coursera class, the videos also seem to be on YouTube. Are they the same?
Same videos, yeah. I uploaded everything to YouTube for broadening participation.
Which one should I take? Why would I take the Coursera over YouTube? I guess they're both free?
Yeah, so Coursera is marketed as free, but then I think it's what happens if you want the credit, they charge you, and you have to be a premium subscriber. But I think also Coursera changes things all the time, so I'm not really sure what the status quo is. I think it's a free class if you don't want to download the certificate, and I think there are certain quizzes that are not available in the free version, which do not add much in terms of content. It's just an additional assessment, and so I think the Coursera class is better because it is actually, when I made it without videos. And so, sorry, I take it back. I made it without lectures. So it had all these mini videos that show examples in robots. But then it has a lot of quizzes which I call guided exercises. And the idea is that you are told or asked to do something in robots. And then I would ask a very simple question that is easy to answer if you have the robot in front of you and you can just press play and see what it does, but very difficult to answer if you don't. So the idea is that you really implement everything along as you go in Coursera. And on YouTube, these lectures just provide some content, but do not provide that guided, self-guided activity.
But then I have to sign up for Coursera. Okay. And then the book, which is for sale on all the normal book sites, I can also compile in LaTeX.
Yes, that's right. It's on GitHub, and the license is that we can make the source code available. And so people have to make their own PDF.
Yeah, that was harder than it seemed, but that's okay. So basically there are free versions of the whole class. How are you going to make any money from that?
I have a job. So, I mean, that is not the primary driver. Actually, there is royalties for the book if people buy it, and there is royalties for the Coursera class if people from outside of CU take it. And I think there's some key on how this is split across the university and the people who created the content. So there are certain, I don't think these money, none of these money sources is really scalable. I feel like it is more part of the profession to see where things are going and, actively contributing to how the university is changing. And that's why, for instance, CU has engaged in this master's program in Coursera. And I don't know if you know that, but you can, if you pass 3 of the classes in the master's program, you get enrolled in the master's program, even if you don't have a bachelor's. So you can now just have a high school degree and enroll in a computer science master's program. And I think it's actually indistinguishable from the on-campus experience. And of course, a lot of people ask questions and wonder, including our own faculty, whether that's the right thing to do, because there's also some kind of gatekeeping idea. And I think what happens is now education is freely available and ubiquitous, and we have to find new ways to make the university a platform rather than a broker of knowledge, an exclusive broker. And funny things happened. I think somebody took this master's degree and then started working at CU in a research lab for money during the summer. And so it creates completely new avenues for people to do their career and engage with CU. People who would never have come to CU as a student are now getting a degree there and interacting with people in various ways, and then moving on with their careers. So I think that's part of the job to explore. And we have awards. So I got an award for the book. And I got an award for the open source activity. So the university libraries are pushing that, or the engineering school, and rewarding professors for being proactive in developing materials instead of just using other people's work to educate.
I'm unfamiliar with the University of Colorado's master's program. I'm familiar with the Georgia Tech computer science master program. That's all online and reasonably priced compared to doing it in person. So what you're saying is that you have an entirely online master's degree in computer science?
Yeah, I think it's actually the same as the Georgia Tech ones, except we have this entry point that is different, which is a mastery-based access. But we also came after Georgia Tech. I think the Georgia Tech one is very well regarded in industry. And so we are trying to, compete in this space, I guess.
Can you imagine going back? I mean, I think we are about the same age given when you graduated and all of that. Can you imagine if this was possible and you could live anywhere and get a master's degree and start your career that way? It just seems so odd to me.
I think it's very odd. And I think 5 years ago, you couldn't have done that. Technically, wasn't possible. Or, I mean, we always had remote universities, by the way, in Germany, where you could get a remote education, and offerings like this always existed. But at that scale, that you can learn so many things by yourself, by the way, without getting the degree, I think that is really the novelty, that you can build or, set your goals to anything and learn it from the internet using YouTube videos and ChatGPT in particular. I think that is really the novelty, and that's where we have to then say, and by the way, we also sell degrees. Do you really need one? And think about what that means.
Do you really need one?
I do think that applies to certain kinds of people, though, because like you're asking, Alicia, can you imagine doing that when we were in school? No, because I would never have finished. I would have goofed off and looked at videos, and then I am not temperamentally set up for that. I need to have people in my face, in person, or some sort of accountability. I don't think I could do a thing like that without just failing out of it.
Yeah, I have the greatest respect for the people who actually do the master's degree, and I often write them letters. And I think they're just so much more capable than, I mean, I shouldn't put it this way, but
yeah.
They are extremely heavily self-motivated. Yeah. Is not what the on-campus students often are, because they behave as you describe. There's a funny other aspect. I mean, if you really want a job and you want the money, then you'll probably do it. And I had a student come to me recently, and he asked me if he should stay on for the master's degree. And I then asked him what his goals are and what his grades are, because maybe he has very poor grades. So then he gets the master's degree, and then he has finally a good grade that he can show. No, he had 4.0. And then I asked him his goals. He didn't really know. He wanted to learn more to be proficient in a specific industry. And I then told him that his goal should be to get a job, because that's why he takes the degree. And now if he cannot get a job because of the economy or his other, limitations of his GPA or knowledge, he wants to get a different job, then yes, go get the master's degree. But I feel like sometimes the students forget that they want the job. And so with this new world of online education, I can look what are the jobs that I want, and I can try to get that knowledge, and then I can demonstrate it. And I had a student once, or actually he was a student and he worked in my company, and he wanted a job at Rivian, and they didn't give it to him because he didn't have certain qualification, I think, with OpenGL. And then he spent a weekend learning OpenGL and programmed this Rivian car, driving in some kind of like muddy something. And he called that recruiter and said, look, I know OpenGL now. Can I have the job? And he did get the job. And so I mean, that was when, 5 years ago, maybe 3, something like that, when Rivian was hot, new. And I didn't realize how easy it was. I mean, not that it was easy for him, but it was possible to learn all of this and find YouTube examples. And at the time, I haven't learned from YouTube yet. I was a textbook kind of guy. So if I would have done this, I would have ordered an OpenGL book from McAfee or something, or what, this thing with the animals on. Oh, really?
O'Reilly.
And I read the entire thing. And then but this younger generation, they are much, he's much more result oriented. He wanted to do this. So he found some example online and he cobbled stuff together, and he got much quicker results than I would have gotten. And so that's why I said he wanted the job, he wanted the money that comes with it, which is much more than he had a mechanical engineering degree too, so they are paid less than the CS people. So I think, Chris, you would be the same if you were motivated to get the job. And now I can ask you why you were, and or we could go into this, but it's also developmental stage where the university serves as a environment for personal growth, and that is a very important aspect too.
Yeah, and I think that was very important for me because I went from a place where in high school everything was somewhat easy and I did very well, and then as soon as I got to college, I suddenly realized that I was, mid-tier to lower quarter tier of this class, and that didn't feel right, and things were very difficult. And it took me a couple of years to figure out, how to apply myself and how to be motivated and things like that. So it's an age thing. Like now I can learn from YouTube videos and I can learn from online classes. And I did a master's degree when I was an adult, and that was self-motivating and stuff like that. But at 18 to 20, that would have been very difficult. But I also didn't grow up with YouTube. So maybe I would be a different person.
But I still have trouble watching things on YouTube. I do so much better with the textbook. How did you switch that?
Yeah, I think it was actually also that student who introduced me to that idea. When I bought books, he was watching videos. I think you need really good stuff. Like I like these Make More from Anjay Karpati, for instance, and that was just, my world, that opened the world for me to transformer neural networks. So I think you have to get to the right content. But normally, to me, it's also too slow. I mean, it is a pacing thing. The book, you can pace yourself, the YouTube video. So you can also set it to 2x. So sometimes you have to do that and power through. And I get, again, I think the content has become so much better on YouTube, on like video formats than you could find on books. So that I think that's really what made the switch for me.
There's a lot more examples and seeing things happen.
And with the robotics, it's actually really useful because I read about the robot that Nikolaus is talking about with the 2 wheels and the one perpendicular and it doesn't fall off the table.
Sure.
And, in the book, it talks about it and you're like, oh, okay. And then when you see it in the video, it's like, oh, that's what he meant. So there are times where motion matters.
Yeah, the podcast audience probably already quite right that they couldn't see the robot that we all have seen and described.
Oh, some of them have already clicked the buttons to look it up. Others have just cursed us on their drive and said, I'll never find it again.
That's fine. We've had much worse visual descriptions on this podcast. Origami folding takes the cake.
What kind of research do you do?
So right now, we are very interested in these ChatGPT like open world models, and how they affect robotics and how we can use them to make robots smarter. And to make that more clear, you can now upload pictures to ChatGPT. So you can take a photo of your kitchen table and ask ChatGPT, what are the things I need to do to clean the table, make a list, or tell it I am a robot, whatever. And it would then enumerate the things. So you get quite a high level of common sense and almost general intelligence to interact with the world. And the research is not just using ChatGPT in that way, but also to train models that are like or using the same underlying techniques to do that. And so then, humanoid robotics is something that is also coming up, and I'm just about to order my first humanoid robot. And then I hope we can do things that were not conceivable like 10 years ago or 5 years ago even.
So for ChatGPT and robotics, I have in my metaphorical vision a Roomba-looking robot that has a pen and is the logo turtle robot from many years ago. And it talks to ChatGPT and says, I want to draw an owl. And I know how to go left, right, and it lists out the turtle logo instructions. Is that what you're talking about? That we're simplifying what the robot wants to do versus what it knows how to do?
That's definitely a great example, because it actually pulls in this extremely abstract knowledge about what an owl is. And what we can do now, if you want, we could go to ChatGPT and ask for the owl ASCII art, to make an ASCII art, like, using characters, and to see if that would even work. But I guess it would, and I guess it could be done relatively easily. And, now you have to just provide, as you said, the API. That's like the prompt engineering you have to do. And then copy and paste the output, and it will work. So
will it?
That's quite incredible.
ChatGPT is doesn't always work.
So the limitation might be that the number of instructions are quite long for this task, and it doesn't like to spit out too much information. But I think you can get to some kind of version of this. And I just saw a paper from Berkeley, Ken Goldberg's group, who showed the robot 3D puzzle pieces, like cubes and triangles, and then asked, make me a giraffe. And then the robot would pick those items and build the giraffe or whatever, like animals of that kind. And there's some more engineering to that, but in general, it uses the vision language abilities of these models, and demonstrates that things like that can be done. So that's very similar to your drawing example. It's just in 3D and involves blocks.
I'll go back to you dropped that you have ordered a humanoid robot.
You dropped that you've ordered a human.
Right.
Not so good.
Why? This is a question we've asked other robotics adjacent people on this podcast in various forms. Why or is humanoid form important?
Yeah, great question. I spend a lot of time in manufacturing trying to sell robots to them, and they often discard them. So as you might know, these robot startups are often not successful. And then, be it arms or be it mobility, they get sent back. And when you then ask, why do you not want it anymore? Then they say it doesn't work. And then you say, no, it does work. It moves as it should. And they say, no, it's... And so I think what happens often is that the robots disrupt the flow. So they cannot work faster or slower. So they basically enforce a certain takt time, which is a musical word which you use in manufacturing for how the pace at which things move. And I think humans are able to adjust better and adapt better. And so it's very difficult to integrate. You have some existing setup with humans that do stuff and machines. And then when you bring in new machines, they disrupt the flow of things. And so I think humanoids are the best bet to create something that very seamlessly integrate. And I have to give you a longer answer, which is, I can give you a second part to this answer, another example. And I often use this Bialetti espresso maker from Italy. It's that silver can that you have to screw on and off and put the powder in, and then you set it on a heat plate.
Oh, yeah.
You know that?
Yeah, like a camping espresso thing, kind of.
Yeah, the Italians actually, they live with it, but that's fine. So
this is how it should be done. It's not a camping thing.
Sorry.
So if you, let's say you have a factory and it has these kind of things, the heat plate and the grinder and this. And so you go to a roboticist and say, hey, please automate that for me. And then for $150,000, you could probably think of something which involves a couple of robot arms and careful jigs that make that work. And I think it would be very brittle. And now the alternative is an espresso maker where you press a button. And that espresso maker actually has the same configuration inside. Everything is the same. It boils water, or it heats water, and then it has this sieve, and the water gets shot through that. And so you basically mimic this entire mechanism, but you can get that done for $300 or $500.
Right.
And so that is one problem. It's called greenfield versus brownfield, where you have a brownfield installation that you want to retrofit versus you can discard that stuff and build something new on the greenfield. And so now I think we haven't really talked about that the robot installation wouldn't really work. I mean, you can see how you have like universal robot arms, and there would be problems all the time that something would get stuck or dirty or fall out. Mm-hmm. And so I think really the only way to deal with this brownfield problem is a humanoid, which is as good as a human, because that's really the only thing that comes with all of the tools, or let's say, I don't know what it is, form factor and functionality to actually replace the human who has previously operated that existing brownfield installation. And so that's the answer.
Because we've adapted all of our environments to ourselves necessarily, so it's much easier to stick a human-shaped thing in a human-shaped hole.
Yeah, and maybe that would be the simple answer, but I don't think people buy that answer anymore. I think they need better concrete examples like that. And of course, it's a made-up example too. And you're right, that is the summary. And people don't want to change their environments and their setup. Very difficult to make even small changes in a factory.
See, I thought you were going to say people wouldn't want to send back something that looked like a human.
It's a nice one.
It's funny how much I disagree with this. I mean, I didn't really expect to have such a strong opinion, but I am just like, no.
It's Sunday. You can't have a strong opinion on a Sunday.
Okay, so
I would use that one, Chris. I like it. It's much easier. I just say it cold, without a smile, just very serious.
Bartender. If I was building a bartender robot, I would not want a humanoid. I would want something with wheels instead of legs, and I would want 4 arms or 8 arms. I wouldn't want a humanoid, even though it's a humanoid that does that job. I want something designed for purpose.
But I
and
think
not designed for the flexibility that is our feeble humanness.
But the bar already exists as it is. That's the problem. The bar
Right, and my robot does not break that in any way with
you
wheels.
haven't designed it yet.
With
there
wheels
are
and
many
forearms.
bartending robot, startups are like cocktail mixing machines. And
Yeah. But that's greenfield, right? They've got all the things in there like an espresso machine.
Yeah, but my robot could do the whole flair cocktail
Well,
thing.
then let's do that startup.
So I think there's a problem that you have only a marginal value prop, and
Yeah, right.
then it doesn't justify all of this mechatronic investment, and the humanoid can really, go and do multiple things. And the problem with this is my example only works if the humanoid is so good that it could do all of this dexterity.
Right. We're just kind of sliding over
things.
that. Yeah.
And once you don't have that anymore, then you'd exponentially lose value. And that's what we are seeing right now when people try, BMW tries to figure humanoid robot. And the problem is if they cannot deliver or raise the bar of value, then this will fall through. And then we have a failed bubble, which would be a pity.
One of the other problems with humanoid robots or my bar robot is that robots are inherently not safe. They're usually stronger than humans, and they don't really have any compunction against hitting us, if that's what their programming tells us to do. And so in manufacturing, we put them in cages or paint lines around them and tell the humans not to go in there.
Put blinking lights and orange paint on them. Yeah.
Yeah, we make them brightly colored so that people don't hurt themselves or get hurt by the robot. How would your humanoid robot prevent that? Or are you going to make it squishy?
Yeah, it's a great question. All of these things, squishy and, collaborative robots, that exist. The key in collaborative robots is that the robot measures its own joint torques. And as soon as it exceeds what it thinks it should exert, it will stop. And so before you had robots that could lift 100 kilograms. And so if you get in the way, they would just move right through the obstacle or you. And these new collaborative robots, they could sense that and then stop. And of course, once you move them faster, then they whip you again. So it doesn't work. And I think one really has to make the robots behave safely, and in the worst case, just stop moving if people approach. And that's, of course, a problem if you think, care situations or, but I think there are lots of applications where the robot actually doesn't have to do anything with humans. So if the robot would do something in the manufacturing environment or cleaning the kitchen, then it's also safe that it gets into a less aggressive motion mode that is moving slower as people approach. And then the assumption is that when contact is made, the robot can tell. And it can tell already from monitoring its own joint torques. And then there's, of course, this whole idea of adding skins to the robot. And there's some interesting... What's that?
And clothing. Sorry, go ahead. Skins.
Yeah, I'm actually really bullish on the idea of making robot clothing, like with the humanoids, like jerseys and things that are functionalized and provide them with, because the textile industry is very well understood, very well set up, and there's lots of ideas for wearables out there to make them, to functionalize clothing. And you start to add another layer of safety and also aesthetic appeal.
I was kidding. Robots shouldn't have clothes.
Yeah, sure.
Robots are people too. You can't just fire them.
You also mentioned before recording that you are doing battery disassembly with robots. Could you describe that?
Yeah, so I just got a new grant starting on January 1st for battery disassembly of lithium-ion batteries. And, a lot of first generation electric vehicles come to end of life soon, and there will be many more. And at the same time, lithium and other rare earths are a limited resource. So there's great interest in, dismantling these batteries and recycling them or remanufacturing them by exchanging individual cells and modules, but then at the end also to extract these raw materials again. And I do this, or I propose to do that with humanoids. And the hope is also to use this as a case study for productive use of humanoids, because it meets this dull, dirty, and dangerous paradigm that we like in robotics. And it is a better idea than making a robotic coffee maker that operates that Bialetti machine, where people can really see, I don't want a human to deal with 400-volt battery or 800-volt battery. I'd rather not be close to that battery when it catches fire, because I, drilled through the, if you drill into it or something, it can just spontaneously combust, and then you can't even put it out. So it's very dangerous, and I think there's a big driver for having humanoids do that. Now, you could also have, many people have done this with static manipulators. But the problem is you have to be able to do this for possibly hundreds of different battery types, and maybe also do this at places where the batteries are being delivered, and not move them across the country first, because that not only costs a lot of money, it's also very dangerous again because of this spontaneous combustion risk, or short circuits that come when you put it on in the back of a truck. So I hope that this will also drive a little bit the humanoid use case.
So instead of having people send all of their batteries to someplace in, well, let's be realistic, Nevada, you would send these robots to various centers, probably on the outskirts of town, and they would disassemble the lithium-ion batteries there, because the robots are humanoid and can move and can be flexible enough to disassemble many different kinds of lithium-ion batteries. Am I understanding properly?
Yeah, that was correct. And there's lots of stuff to unpack, of course. And one is this very many different kinds of things is, again, like a ChatGPT idea, like this open world abilities of these generative models, multimodal generative models will help you to identify screws and balls and things in a more generic way. So even if you haven't seen that type of battery before, you might be able to disassemble some of it, or ask then a human worker how to do it. But also the humanoid would provide the mobility that is allowing the robot to move around the battery, because sometimes they're bigger, and you would need quite a big installation that is statically, and like a big coffee machine, if you want, espresso maker that sits somewhere and costs hundreds of thousands of dollars, versus having a rather simple, it's not simple, but a more compact version that can use standard tools that people are currently use. And of course, this assembly is not going to be completely autonomous in the beginning, but it must be somehow working together with the human worker. So let's say the humanoid could only do the things until the battery is safe, or for example, opening up the case and probing what is inside, and then the human can take over. So, and because it is a fluent process where you automate it step by step, I think that's why the humanoid form factor again is important, so it can integrate with the existing places, because people already do this for like 10 years now to, dismantle these batteries and sort them and send them to these big plants in Nevada and other states, but, send other pieces elsewhere. So it's already happening, and it's about that market to help them doing it better.
You call them humanoid robots instead of androids. Why?
Android is an operating system from Google now, isn't it?
Okay, that's fair. Totally fair. Yeah, now that you say that, it does sound familiar. Yep.
I don't think they should be allowed to have that one.
I think maybe is it also Latin and Greek? No, is andros means man and human.
That's true.
I usually use, I don't use the word Android for it. Just culturally, it hasn't. Are you using Android over humanoid?
No, I use an iPhone.
No. You're very funny.
No, I don't.
I tend to use robot.
I tend to use robot.
Not specific enough, but yeah.
I just have, I read a lot of science fiction, and it seems like that terminology has been changing. And it didn't occur to me that it was because of Google and their misuse of their operating system.
Google and gender specific. I think that was what he was saying, right?
I understand that, but I guess it doesn't, that one doesn't bug me.
You could always use droid, but then you'll be sued by somebody else.
Yeah, exactly.
Disney.
One more question I have for you, if you have just a couple more minutes.
Sure.
You do art. And what kind of art do you do, and how do you find time for it?
I haven't done it in a long time. That answers the second part of your question. But, there's always, I think most of the robotic projects are art projects because you're not use-oriented and you're not solving anybody's problem, but you are pushing the envelope. And if you are too wild about that, then people will get back to you and stop funding that and say, no, why do you want to do this? What's the point? And you say, no, it's just cool. I want to try that. I want to make robotic sand, or I want to make robot swarms. And so if that's your problem, then maybe art is the better label. And I think I met once a colleague, Michael Theodore, and he had very similar interests than I in terms of swarming and how it can be that you have atoms that have physical intercourse, like it's really simple to describe, but then they create cell or molecules and then cells, and then you have smart things, or a bee swarm or galaxies, and you have these scale-free phenomena where these physical basic interactions turn into these complex systems. And he was equally curious about this as I was, and he wanted to explore it with art. And so we worked together, and we built the swarm wall, which was a wall of swarming slinkies that would just, driven by servo motors, move across a surface that he designed. And the behavior of that system then later was refined by a visiting professor, Ken Sugawara, who has been studying swarming and writing about the equations of swarming. And what happens is you attribute more to these things than actually happen. So you think that thing has emotions or it is somewhat intelligent because of the complexity that you get from these interactions. So that was a fine example of why I would do art and how I would find the time, because it is just my main pursuit. And we also got money for that, even to build the whole system. And then at the same time, there are sometimes just artifacts of the robots that I find interesting beyond the publication value that they have. And I then like to connect this to other, art where people explore similar phenomena. So I really like these synchronization and desynchronization things, which also happen in the swarming systems. They happen in the swarm wall. And then I like to sometimes play with these and see what happens, and then also connect it to music that is made in that way and things like this. It's not very exciting for other people, but it's very exciting to me. So I think that's probably the definition of art, by the way.
It's a different definition than I'm used to, but I like it a lot. Nikolaus, it has been wonderful to talk to you. Do you have any thoughts you'd like to leave us with?
No. Keep on building, I think. Keep on blogging and try to educate yourself and others. I think that's what makes the world go round.
Our guest has been Nikolaus Correll, professor of computer science at the University of Colorado and author of Introduction to Autonomous Robots. There will be links in the show notes to his Coursera course and some of the robots we've talked to.
Thanks, Nikolaus.
Thank you, Chris. Thank you, Alicia. Bye-bye.
Thank you to Christopher for producing and co-hosting. Thank you to Nordic for sponsoring the show. And of course, thank you for listening. You can always contact us at show@embedded.fm or at the contact link on Embedded FM. And now, a thought to leave you with. Should robots be humanoid?